Okay, so for 3.4 example 1, we're going to look at the method of completing the square to solve these equations. So let's go over really quick. The main idea with this equation is if you have something that looks like x plus r squared, that if you FOIL it out, you do x plus r times x plus r, what you end up getting is x squared plus 2x times r plus r squared. And likewise, if you have x minus r squared, that will give you x squared minus 2xr plus r squared. So the idea of completing the square, very briefly, is to take something that looks like one of these things we have here, take one side of it and write it in this format. The version on the right. And if you can do that, if you know it's in this form where there's some number instead of r, then you can just go ahead and factor that into the version on the left. And once it looks like the version on the left, then you can solve it the way we did with exercise 1 here. The same idea. So let's start with this one. If we have x squared plus 4x minus 6, I'm going to complete the square using the same set of steps on this left side here. So the 4x here is the 2 times r x part. So that means 2 times r must be equal to 4. So if you divide both sides by 2, you get r equals 2. And so r squared is 2 times 2 is 4. Okay, so that's what we need to have added to this. So I'm going to write this as x squared plus 4x plus 4 minus 4, and then that minus 6 equals 1. So again, 4 minus 4 minus 6 is the same as just negative 6, because 4 minus 4 is 0. So now this part here, we can factor that. That is a perfect square trinomial, so we can factor that into x plus 2 quantity squared. That's all right here. And then the negative 4 minus 6 is just negative 10. So now we have an equation just like in exercise 1, where you have something, the x only shows up inside of this thing being squared. So you can isolate that part and then cancel that out with a square root. So I'm just going to add the 10 to both sides. That'll give you x plus 2 quantity squared equals 11. And from there you can just take square roots of both sides. Don't forget the plus or minus on one side. And that'll give you x plus 2 equals plus or minus root 11. And you can just subtract 2 from both sides from that. And that gives you x equals negative 2 plus or minus the square root of 11. All right, so that's that. Now, what about the 3 here? You could divide both sides of the equation by 3 if you want. That's fine. That's actually maybe an easier way to do it, but I want to try to use the same method as I did in section 3.3. Just for consistency, I think it might be easier to understand. And the thing I did in section 3.3 is factor out the 3 from these two terms. So let's do that. We're going to write this as 3 times x squared plus 4x. And then there's still the minus 9 equals 0, because 3 times x squared is 3x squared. 3 times 4x is 12x. So now that you have this x squared plus 4x, that 4x is that x squared plus 4x, we're going to deal with that the same way we dealt with x squared plus 4x over here, which was by having a plus 4 minus 4 and throwing that in there next to that. So one, it doesn't change it, and 2, you have a plus 4 written there. So this is going to turn into 3 times x squared plus 4x plus 4 minus 4. That's all in the parentheses, so that this part here can now be a perfect square trinomial. And then there's still the minus 9 on the outside. So this part I have in the bracket, and the red line on top, is going to turn into x plus 2 squared minus 4, and then a minus 9 on the outside equals 0. Now we could distribute the 3 in there, I guess. There's various ways. You could like add the 9 to both sides first and then divide by 3. There's different ways you could go about it. But I'm going to take this 3 and distribute it in there, so it does look like the same order I was doing things in section 3.3, just to be consistent. So this will give you 3x squared, 3 times x plus 2 squared minus 3 times 4 is 12, and then there's a minus 9 on the outside. And negative 12 minus 9 is negative 21. So at this point, we're going to add 21 to both sides. I'm going to run out of room here. I didn't quite leave enough room on the page. So that leaves 3 times x plus 2 squared equals 21. Divide everything by 3. That'll leave you with x plus 2 squared equals 7. Let's take square roots of both sides here. And this is going to turn into x plus 2 equals the plus or minus square root of 7. And then you can just subtract 2 from both sides of that. So you'll get x equals negative 2 plus or minus root 7. Alright, so that is there's two solutions. X equals 2 plus root 7 and x equals, what did I say? X equals negative 2 plus root 7 and x equals negative 2 minus root 7. Alright, so that's that. With this one over here, we're going to do the same idea. Factor out that 4 from those first two terms over there first. So that's going to look like 4 times x squared minus x, and leave the minus 5 alone, equals 0. So this negative x here is the negative 2xr term, or negative 2rx. So that means 2r must be equal to 1. So if you divide both sides by 2, you'll get r equals 1/2. Okay, so what is r squared then? If you do 1/2 times 1/2, you'll get r squared is 1/4. I'm writing as small as I can because I'm going to run out of room. Hopefully it's not too messy. Oh, I see, I just made it worse. Okay, so r squared is 1/4. So that's what we need to have added and subtracted in here. So this is going to look like 4 times x squared minus x plus 1/4 and then minus 1/4. So that's not actually changing anything. And then there's still the minus 5 equals 0 on the outside. And now this stuff that I'm going to put under this red bracket, that stuff is now x squared. That minus x there, you can think of that as minus 2 times 1/2 x. Now I really can't write any smaller than that. So that's the minus 2xr, with the r is 1/2 there, and the 1/4 there is 1/2 squared. So that is in the form of the second one, so that's equivalent to x minus 1/2 squared. And there's still the parentheses on the outside here with that minus 1/4 in there. And then that minus 5 equals 0. Alright, so then we're going to distribute the 4 in here. That's going to give you 4 times x minus 1/2, quantity squared. 4 times negative 1/4 just cancels out to give you minus 1. We still have that minus 5 here. And then negative 1 minus 5, I'm just going to save a step because I'm going to run out of room, and write that as minus 6. So that 6 is what you get when you do, minus 6 is from doing 4 times negative 1/4 and then that minus 5. So That's all that. Now we can add the 6 to both sides. That'll leave you with 4 times x minus 1/2 squared equals 6. Divide everything by 4, and you'll get x minus 1/2 quantity squared equals 6 over 4, which reduces to 3 over 2. Okay, so then we can take a square root of both sides. Don't forget the plus or minus on one side. And then we'll have just x minus 1/2 left equals the plus or minus square root of 3 over 2. Now we're going to add 1/2 to both sides here. And that will just leave you with x equals 1/2 plus or minus the square root of 3 over 2. So for example 2 here, we're going to do the same method, but what if we don't know what A and B and C are? What if we're just going to treat, like, with this one we had A equals 1, B equals 4, C is -6. Oh, not exactly, you'd have to move the 1 over. Sorry, with this one we have A equals 3, B equals 12, and C equals -9. And we can go through all of these steps, just like this, and complete the square that way, and solve it that way. And we're going to do, but what if we wanted to do the same thing, but as if you don't know what A and B and C are? That's what this one's about. So let's see, how would you approach this in general? Well, I'm going to try to do the same thing. First of all, I'm going to factor the A out from there. So we're going to have x squared plus, well, let's see, what would we have times x here? A times something that needs to give you B. How about B over A? And this is a problem that you don't need to know how to do this kind of, this problem. This is sort of advanced stuff, but I think you can learn a lot from watching it. So, there's your B over A thing. The A is now factored out, so we're leaving the C on its own there. And now, let's see, so the X is like the B over A, I meant to say. B over A is the 2R part. Usually I wrote it the other way. So we have 2R is B over A. So if you want to divide both sides by 2, you'd get R is, well, remember that dividing by 2 is the same as multiplying by 1/2. So that would give you B times 1 over 2 times A in the bottom. So R is B over 2A. And that means that 2 times R is the B over A part. So that works. Now, what is R squared? That would be B over 2A times itself. That would be B squared over 2 times 2 is 4. A times A is A squared. So that's the thing we need to have added on to the middle here, inside these parentheses. And then we also need to subtract it so that we're not actually changing the equation. So that's going to be A times x squared plus B over A times x plus B squared over 4A squared minus B squared over 4A squared. And then we still have the plus C and still equal to 0 there. Try to keep that from getting mixed up. Okay, so now this part I'm going to put under this red brace is now a perfect square trinomial. That should be equal to x plus r squared, but the r is now b over 2a. So we're going to write this as a times bigger parentheses there, and then x plus r, well, sorry, but instead of r, that's going to be b over 2a. So there's your x plus r squared part. There's still everything else here. The minus b squared over 4a squared, and the plus c and the 0. Now, but that part has now been turned into this using the perfect square trinomial formula. So let's see. Now we want to get that part by itself, the x plus b over 2a squared part by itself. So I'm going to redistribute this a into these two terms here. So that will now look like a times x plus b over 2a quantity squared. And then we're going to have that, minus, well, let's see, it's going to be a times b squared over 4a squared. And remember, a squared is really a times a. So we can see how this is going to reduce. So this a got distributed in here, but now one of them is going to cancel out with an a in the bottom. Oh, and don't forget there's still a plus c equals 0. Almost forgot that. So let's see, we just have b squared minus 4a left over. So all of these terms, I'm going to move them to the other side of the equation. So I'm going to subtract c from both sides and add b squared over 4a to both sides of the equation. Doing the same thing to both sides. So this is now going to look like just this bit here is what's left over because those other terms canceled out. And that's going to be equal to b squared over 4a minus c. And this is going to look a lot nicer if we can combine these into one fraction, the b squared over 4a minus c. So what I want to do is make it so they have the same denominator. So remember, c is the same thing as c over 1, right? Now you can multiply things by the top and bottom without changing it. So I can multiply the top by 4a. I can multiply the bottom by 4a. That's going to give you 4 times a times c in the top, and in the bottom is just 4a. So you have something over 4a minus something else over 4a. So that's going to really be the same as b squared minus 4ac divided by 4a. And everything over here is the same. Okay, so now I want to cancel out this a, so I'm going to divide both sides by a to cancel that out. And dividing by a is the same as multiplying by 1 over a. So this is going to give you just, I'll write it over here. We've got some more room. X plus b over 2a quantity squared equals b squared minus 4ac divided by 4a squared. All right, so now we can take the square root of both sides here to cancel out this squared business. We want to include a plus or minus on one side. And let's see, this is going to leave you with x plus b over 2a. On the other side, well, we're going to have the plus or minus square root of the top and the square root of the bottom too. In the top, you have these different terms, and the square root doesn't distribute over those. And then but in the bottom, you just have 4 times a squared. That's the same thing as 2a quantity squared. That 4a squared there is just equal to squaring 2 times a, because you do 2 squared and a squared. So those square roots just cancel out, And this just ends up being x plus b over 2a equals the plus or minus square root of b squared minus 4ac. And in the bottom, you just have 2a. And this might be looking familiar. I'm going to subtract b over 2a from both sides here to get the x by itself. So what we're trying to do is solve this whole equation, right? And we'll get x equals, well, let's see, you have a fraction over 2a and another fraction over 2a. They have the same denominator, so you can combine them. So you can write this as negative b plus or minus the square root of b squared minus 4ac over the whole thing over 2a. And that is the solution of the original equation. So it just depends on what specific numbers you have for a, b, and c. So if you want to solve any equation that's written in this form, you could essentially skip all of these steps, because let's face it, these steps are kind of a pain in the butt. There's a whole lot of them. There's a lot of weird things you have to do with fractions that you might not be used to. Some complicated things we've barely gone over with the way square roots cancel out with this stuff. So you don't want to have to go through all these again. You could just go straight to the end. You could say, I know all these other steps in the middle must work, and I know this is the result of doing that. So this big complicated expression with a, b, and c in it must be the solution of the original equation. Just plug in your b and your a and your c and do the arithmetic it says to do, and you've got your solution. So this is, of course, the quadratic formula. This tells you the solutions of, I'm going to write this again here, ax squared plus bx plus c equals 0. So yay. This is a super handy, super useful formula that you've probably seen before. And it's one you've got to memorize, because it's definitely the easiest way to solve quadratic equations. So let's do some examples of using this quadratic formula. So if we have x squared plus 4x plus 5 equals 1, well, does this say ax plus bx plus c equals 0? Does it look like it's in that form? Well, almost. The problem is it has a 1 here instead of a 0. So we gotta, turn that 1 into a 0 by subtracting 1 from both sides. That will leave you with a 0 there. And then on the other side, you'll have x squared plus 4x plus 4 equals 0. Oh, wait a second. Does this equation look familiar? Is this the same as... Oh, no. It's not exactly the same as example 1a. Just kidding. Okay. So, anyways, so this x squared you can think of as 1 times x squared. So that means your a is 1, your b is 4, and your c is 4. So that's what we're going to do. We're going to take those values of a, b, and c and plug them into this. So this is going to give you x equals negative b is going to be negative 4 plus or minus the square root of b squared is 4 squared minus 4 times a is 4 times 1 times c, which is 4. So it's b squared minus 4ac there, divided by 2 times a. Oops, but the a is 1. So this is the arithmetic we need to do. It's important to keep track of the order of operations here. And also, there's a lot of mistakes people get when they get sloppy here. I would just say try really hard to write it as clearly as you can, so that you don't get order of operations mixed up, or so your handwriting doesn't mess things up. So let's see. The negative 4 plus or minus, I'm going to leave that alone because we got to simplify this part first. So we have 4 squared minus 4 times 1 times 4. 4 times 1 times 4 is 16, so is 4 squared. So this is going to be 16 minus 16 in there, which is 0. The square root of 0 is just 0. So this is going to be and 4 plus negative 4 plus 0 and negative 4 minus 0, it's the same thing. So we're just going to ignore that, and it's just going to be negative 4 over 2, and it gives you x equals negative 2. So that's the solution of this. Let's do the same idea here. It's just this time your A is 4, your B is also 4, and your C is 5. And we do have 0 on the other side this time. So let's plug it all in. We're going to have negative B, negative 4, plus or minus the square root of B squared minus 4 times A times C. That's 4. B squared minus 4AC is 4 squared minus 4 times 4 times 5. Lots of 4's here. And then in the denominator, we're going to have 2A, which is 2 times 4, or 8. Okay, and inside this big square root, we have 4 squared, which is 16, minus 4 times 4, 16 times 5 is 80. So this is going to be 16 minus 80, which is a negative number in the square root. Negative 64. Okay, so that is what is a number you can square to get negative 64? It would have to be an imaginary number. There's no real number you can square to get negative 64. Because of course negative 8, if you think it might be negative 8 squared is negative 8 times negative 8 is a positive 64. So this does not have a real number solution. And if you want to see what this looks like on a graph, I think that might help explain why this has no solution. So to do this on a graph, we're going to graph y equals 4x squared plus 4x plus 5. And that graph gives you a good picture of what kinds of values the left side of this equation can take on. So I'm going to write y equals 4x squared plus 4x plus 5. And what you see here is that you have values of y like negative 4 is the smallest value of y. Then you have 5 for y here, or 6 for y over here. But there are no values of y that are less than 4. In particular, there's no values of y here that are equal to 0. So it never crosses the x-axis. So I'm going to copy this over here so you can see what this looks like. So yeah, here's where y would be equal to 0, but there are no points on the graph where it's equal to 0. And what about this one? Well, if this has one solution, what does that tell you about the graph of x squared plus 4x plus 4 equals 0? Well, there's probably just going to be exactly one point where it's equal to 0. Let's graph that one really quick. This was y equals x squared plus 4, or x plus 4. And yeah, there's exactly one point right here where it crosses the x-axis. So there's one value of x that makes y equal to 0, and it's right here. negative 2. Okay, so how about this one? Let's see what happens when we solve it, and then maybe we can draw a graph of this too. Okay, so first of all, you have to get 0 on one side, so we need to subtract 12 in order to use the quadratic formula, because again, it only works when you have this 0 over here. So this is going to be 5x squared plus 11x minus 12 equals 0. And this would be a really tricky one to complete the square with. You'd have some very messy fractions with it. So the quadratic formula is much easier. So I'm just going to write this down, but with a b equals 11, so that will be negative 11 in the top, plus or minus the square root of 11 squared, minus 4 times a, which is 5, times c, which is negative 12. Here, and in the bottom we're going to have 2 times 5, which will become 10. We might need a calculator for help with some of this arithmetic. I might be able to do it though. 11 squared is 121. 4 times 5 times 12 is going to be 480, and then 2 times 5 is 10. So we're going to have 121 plus 480 will be 601, and that's all getting divided by 10 here. Okay, so we got that. These are pretty awkward numbers, so maybe we should use a calculator to cancel out that, or to simplify this. So this is going to look like in the top we have negative 11 plus the square root of 601, all divided by 10. That's 1.35. And then, so that's doing the plus version. You just have to hit second entry to bring this up again, where you can replace the plus with a minus, and you'll get negative 3.355. So that's a good decimal approximation of this. It was 1.35, or x is approximately negative 3.55, yeah. Okay, so this one has two solutions. So what is that going to look like if we were going to graph this? If we were going to graph y equals 5x squared plus 11x minus 12 equals 0, like how many values of x are there going to be that make the result of this, the y coordinate, equal to 0? It should be 2, because we got two solutions here. So let's just go to Desmos and check that. We're going to have y equals, I just realized the edge is cut off here. Y equals 5x squared, what was it, minus 11x plus 11x, excuse me, minus 12. And here's your two solutions. We have 0.8 and negative 3. I must have made a mistake. Let's see where that mistake is. Okay, I found the mistake. Whoops, right here. This 480 was supposed to be 240. Whoops. Okay, so this is 240. Let me fix the mistakes in red here. 121 plus 240 is 361. And 361 is 19 squared. What is the square root of 361? Yeah, 19. So that's just going to become 19. So, all right, scratch that. This is going to become x equals negative 11 plus or minus 19 over 10. So let's see, negative 11 plus 19 is going to be 8. Or if you do negative 11 minus 19, that will give you negative 30 over 10. So it gives you x equals 8 over 10 is 0.8, or x equals negative 3. So hopefully those are the solutions. This is why solving by graphing is a good idea, because it's always a thing you can do to check your work. People make mistakes all the time. And yeah, that's what I should have gotten, is 0.8 and negative 3. Okay, so those are the, select this thing here. It's not working. Okay. Anyways, those are the two values of x that make y equal to 0. So you can see with the graph of a parabola, there's basically three things that can happen. Like in terms of the number of places the graph can intersect the x-axis, or the number of values of x that will make it so the y-coordinate is 0. There's either going to be one intersection point if the vertex is on the x-axis, or there's going to be no intersection points if it turns around above it or below it, or it could have two if it goes through in two different places. And the way you can tell which one of those it's going to be without actually going to the trouble of graphing it or actually like doing the whole quadratic equation is what's happening here is there's a few different things that could happen. Let's look at what happens inside the square root. In this case, the b squared minus 4ac turned out to be 0. And when that is 0, plus or minus 0 just gives you one number. So that means if b squared minus 4ac is equal to 0, then your quadratic equation here is going to have one solution. So that's what this is talking about. The discriminant of ax squared plus bx squared plus c, that should say c there, is b squared minus 4ac. So, that's a thing inside the square root. So now, if that's equal to 0, like that first example, then the equation has one solution. If you have something like the second case here, let's look at what was the b squared minus 4ac here. It worked out to be negative 64. And the square root of negative 64 is just not a real number. So the quadratic formula is going to give you no solutions. And that turns out that on the graph, it ends up looking like that, where it never crosses the x-axis. So that means the equation has no solution. Now, if the b squared minus 4ac is greater than 0, let's see, here was the b squared minus 4ac. In this case, it turned out to be 361 after a couple of mistakes, but we ended up fixing it. Then you're doing the square root of a positive number, and you're doing plus or minus a number. And if that number's not 0, you're going to get two different results here. So that's this situation. If this is positive, then the quadratic formula gives you plus or minus a non-zero number, which is two different numbers, which gives you two solutions. So that is called the discriminant. So you can use that to quickly figure out how many solutions an equation is going to have by just doing b squared minus 4ac. And it's called the discriminant because it allows you to discriminate certain quadratic equations, meaning like without actually looking that closely at them, figuring out how many solutions they have. So this is an okay kind of discrimination. Nobody's getting hurt. Quadratic equations don't have feelings, and you're not really oppressing them when you discriminate against quadratic equations. So this is okay. Some of my best friends are quadratic equations, okay? They say it's fine. All right, so anyways, you've got a couple exercises to do, a few exercises. They're kind of tricky. Let's give them a shot before you see the next video.